Hello guys, welcome back to my channel Average Programmer. Today we are going to discuss about insertion sort algorithm. We will recall what we have discussed in the merge sort algorithm. In merge sort algorithm, we use the algorithm of divide and conquer, whereas in this insertion sort algorithm, we will divide the given array into two parts. One is sorted subarray, another is unsorted subarray. The time complexity of solving the problem is big O of n square, whereas n is the size of the array. Let's consider this example and implement insertion sort on this problem. Given array of size 6, 6, 4, 1, 8, 70 is the given array. We have to divide it into two parts. One is sorted subarray, another is unsorted subarray. Subarray means it has to be the continuous array. If you consider 6, 4, 1, it is a subarray. If you take 6, 4 and 8, it is not a subarray. Subarray means it needs to be in the continuous manner. Okay. How we can divide this array into two sorted and unsorted subarrays? Consider the first element of this array. As we know earlier, a single element array is always considered to be a sorted array. So what we will do is divide this array as first element and the rest of the array as unsorted array. As first element is a sorted array, rest of the array is unsorted array. And for implementing this insertion sort, we have to store the first element of the unsorted array in a temporary variable. We will store the 4 in the temporary variable temp. Now we can remove this 4 from this index as we have stored it in the temporary variable. Now we have to compare the temp with the last element of the sorted array. I mean not the last element, we have to compare it in the sorted array in the reverse manner from the last of the sorted array. As there is only single element, we will compare it with the 6. What we have to compare is 6 is greater than 4. Consider this index as I. We have to compare is if a of I is greater than temp, right? If this condition is right, it is not in the sorted order. That means 6 and 4. We have to get 4 in the earlier part, right? So what we have to do is shift the 6 to next element, right? Next index. We have to shift 6 here. So what we will do? Take the 6 and keep it in the next array. And now there are no elements left to compare in the sorted array, right? Then we will keep the temp in the remaining index of the sorted array. What is temp here? 4. Now the sorted array is moved in the right direction by one index, right? So length of the sorted array increased. Now we can see 4 and 6. Now the length of the sorted array is 2 and the length is increased, right? We do the same thing what we did earlier. Consider the first element of the unsorted array. Right side of the red line is unsorted array, right? First element is 1 and store it in the temporary variable. And we have to compare from the back side of the sorted array, right? First we have to compare temp with 6, then with 4. Until when we have to do this one? If a of I is greater than temp. 1 is greater than 6, right? We will check this. A of I is here. A of I is greater than 10 means 6 is greater than 1. This condition is right. So then what we have to do? We have to shift the 6 by one element, right? A of I plus 1 equal to A of I. That means A of I plus 1 means next index. We have to shift the present value to the next index, right? Now 6 will be shifted to here. We will remove 1 and 6 will be shifted to next index. Similarly, we will compare it with the 4, the next element of the sorted array, right? Next element of the sorted array is 4. 4 is greater than 1. This condition is also right. So then what we have to do? We have to shift the 4 by one index, right? We will shift the 4 to next index. There are no elements to compare, right? Then we have to keep the temp in the remaining index. What is the temp? Temp equal to 1, right? we'll keep 1 here. Now as we can see, the sorted array is moved by one index right. Then it is the length of the sorted array is increased, right? Yeah. Now as we can see, the resultant array is this one, 146872, right? This is the sorted array. This is the unsorted array. Now we'll implement similarly to this 8. This is an exceptional case, right? We'll see how. 8 is the first element of the unsorted array. It is stored in the temporary variable, right? Now we'll remove 8 from this index. Now we have to compare it with last index of the sorted array. This is the last index of the sorted array. What? A of I is greater than temp or not. That means 6 is greater than temporary variable is 8. This condition is wrong. Then what we have to do? A of I plus 1 equal to temp. Whenever this condition fails, then we have to keep the temporary variable in the next index. Why we have to do that? The last index of the sorted array is less than the temporary variable. That means we have to keep it in the next index of this last index, right? If I is the index 6 and the next number is greater than 6, then we have to keep it in the next index, right? So we will keep 8 in the next index, 8 here, right? Now the sorted array is moved by one index, right? And the length of the sorted array is 4 now. And the rest 2 are the unsorted arrays, right? We'll continue this until the last element is also a sorted array. Let's do this again. We'll store the 7 in the temporary variable, right? 7 temporary equal to 7. We'll compare it with this is I. A of I is greater than 7, right? A of I is greater than temp, that is 7. So we will move the 8 to next index. Now we will compare temp with I. I will be moved here, right? We will compare temp with I. A of I. If A of I greater than temp, then 6 greater than 7, as it is wrong. We discussed that if this condition fails, we have to insert temp in the next index of the condition failed. We have to insert, if condition failed at A of I, we have to insert temp at A of I plus 1. This is A of I. I have to insert temp in the A of I plus 1. That means here. So this is a sorted array, right? This is the main idea of the insertion sort. We'll take the element from the unsorted array and insert it in the sorted array by traversing through it in the backward direction. So we will insert it in the place, right? Now we will discuss its algorithm. We'll see it in the action. I have taken the same array we discussed in the problem 641872. We'll write code for it. Okay. First, what we have to do? For I in range of 1 comma n. Why I am writing from 1 to n is this is the range of unsorted array. The range of unsorted array starts from 1, right? As 0th index is the sorted array, we will consider 1 to n minus 1 as the unsorted array. Now we will pick the first element of the unsorted array as temporary variable. Temp equal to A of I. Right? Now, what are the conditions we need to write? While we need to traverse through the sorted array, right? In the backward direction, we can write j equal to I minus 1. Why are we writing this? If this is I in the first iteration, this is the I minus 1, right? That means the last element of the sorted array. Now, How until when we have to traverse in the sorted array? While j greater than or equal to 0. That means first element of the sorted array, right? Less than 0, there are no elements, right? It will get array out of index error. And a of array of j is greater than temp, right? If this condition fails, then we have to break it, right? If consider this scenario, here 7 is at the temporary variable, and if 8 is shifted to this part, now comparing it with the 6, 6 is greater than 7. This condition fails, right? Then what we have to do? We have to keep a of I plus 1 equal to temp, right? Here, this condition fails. Then, if both these conditions are true, then what we have to do? We have to shift the current element to next. A of j plus 1 equal to a of j, right? Otherwise, this condition fails, a of j plus 1 equal to temp, right? Did we miss anything? No. Yeah, we have to decrement the j minus equal to 1, right? Yeah. Now we will execute this problem. I'm printing the array before sorting, and I'm also printing the array after sorting. Yeah. Before sorting, array is 641872. After sorting, we can see array is sorted 1 2 4 6 7 8. This is the insertion sort algorithm. If you have any doubts, please put it in the comment section. I can make a video on doubts if you have many doubts. Hope you understood what is insertion sort. Meet you in the next video.